The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
We're going to need to become comfortable with a few definitions, and we'll commence here with work, more specifically the derivation of our work equation, and then we'll cover a few more equations in our next slide before we get into our problems. Now, from our physics lectures, we know that work, as it says here, is the product of force and distance. Furthermore, we also know from our physics lectures that force, if we come down here to figure 7.3, force is also the product of pressure and area. Now, if a reaction takes place as it is here in figure 7.3, right, and the gas expands, meaning the volume of the gas is increasing as we see here, then the piston changes position. As we see here, it goes from here to here, it changes position, and that change in position, as we see here, is against the atmospheric pressure, right? That's against the atmospheric pressure. And when it's against the atmospheric pressure, if we come back up here now to our equation, that's why it's negative. Thus, force is also equal to the negative sign here, right? And is the product of the external atmosphere pressure, and that's why it's negative, times the area of that piston. Now, if we actually were to take that term there and we were to plug it in for force in our work equation, we end up with the following, where we have the external atmosphere pressure times the area of that piston times the distance, right? Furthermore, we also know that the change in volume for a system, as it says here, is area times distance. Now, if we were to plug that into our equation, we end up with the following equation, where work is actually equal to the external atmosphere pressure times the change in volume. Now, intuitively, it should also make sense that work is going to be negative and energy is going to be negative. If we take a look here at figure 7.3 once again, as we see here, the system does work to move the air molecules here, right? It makes sense then that the system is going to be losing energy, right? Thus, our work and our energy is going to be negative. Wonderful. Now let's actually take our equation here and let's actually build on it on the next slide, and we'll concentrate more now on the energy equations. Great. Energy and enthalpy equations. Now, before we continue with our equations, I have a quick question for you. With molecules, where is the energy released from?